Hi folks, this is part 3 to lesson 4, and what we're going to do now is take all the things we've learned about rational functions, put everything together, and we'll have an algorithm for sketching these functions. Okay, now you'll notice that I've used the same one which was in number 2, and it's already in factored form, so we'll start with this as our base, and then we'll get to some examples where we have to do the work to get to this factored form. Okay, so this has been factored. I see here again that there's no common factors in numerator and denominator, so nothing reduces. I'm not going to have any holes. Okay, so let's move on to the first part of our algorithm. And the first thing I'm always going to ask you to find is the domain. So essentially you have to determine all the valid x values, and the only thing that's going to cause a problem here is anything that makes the denominator equal to 0. So our domain is going to be all x values that are real numbers such that x is not equal to, well, -3, since that'll make the first factor in the denominator 0, and 4, which will make the second factor equal to 0. Okay, step number 1 is determine what domain values you're even working with. Then we'll move to x-intercepts. Okay, so the x-intercepts are where the numerator is equal to 0, and we can just read that right off since it's already nice linear factor. We know the only x-intercept is -1. Okay, let's move on to the vertical asymptotes. Okay, the vertical asymptotes occur wherever the denominator is equal to 0. Now notice here, if I just put -3 and 4, those don't work because -3 and 4 are numbers, whereas vertical asymptotes are lines. So I need to make sure I put their equations. So my vertical asymptotes are x equal -3 and x equals 4. Okay, not putting this gets you half a mark off for not correctly stating the asymptotes. Okay, now before I get to the end behavior, we're not putting a lot of stock into the y values these days because we still have the same problem as we had with polynomials. We still don't have a method for determining maxima and minima, but something that is helpful for determining, for sketching the graph is at least the y-intercept. Okay, so what is f at 0 equal to? Well, let's put this in. 0 plus 1 is 1, 0 plus 3 is 3, and 0 minus 4 is -4. Okay, so we see that the y-intercept is just -1 over 12. Okay, so it might be something we'll use when drawing the graph later on. Okay, next major characteristic, of course, is the end behavior. Okay, notice, by the way, all the shorthand I'm using. Okay, that's perfectly fine. So the end behavior here is how this function behaves when x gets really large or x gets really small. So while it's in factored form, a little easier to see if it's in standard form, is we can easily see that the numerator has degree 1 and the denominator has degree 2. So because the denominator has the bigger degree, our end behavior is that this function is going to be approaching 0. So as x approaches positive or negative infinity, y is going to approach 0. Okay? Or I guess I could have written f at x is going to approach 0. So we have our end behavior. Okay? However, the other thing that's going to be helpful for drawing the graph, so for example, is this approaching 0 from the positive side, from the negative side? Well, guess what's going to help us with that is to determine the sign of this function. Now, we've already done the work for that back in number 2. So the next thing that you want to determine is the sign of your function, and we went through that process. For this one here, since we've done the work, I'm not going to redo it, but the idea is that on your number line, you put everything that makes your denominator or numerator equal to 0, because those are where the function can change sign. So we had -3, -1, and 4. Oops, -1, going a little fast here, and 4. And we already determined from our previous question that it was going to be negative in this interval, positive, then negative, and then positive in those intervals there. So now what we do is we take all this information and we're going to draw a graph. Okay, so now I'm not going to worry too much about a scale on the y-axis, because I'll just choose whatever scale makes this y-intercept work well. But I do want to look at my vertical asymptotes and my zeros. Okay, and these are all relatively small numbers, so I think on my x-axis I can just go up by 1. Okay, so let's get axes on here. So let's get a y-axis, and I'll just put the x-axis right down the middle. There we go. I'll wait for the y-axis, but I know that I want these to go up by 1. And the first thing we should set up is our x-intercept. There's only one of them, so at -1 we have an x-intercept. The next thing that I'm going to draw is my asymptote. So we're going to see that I'm going to draw a structure to this graph, and then I'll worry about figuring out where everything is going. So -1, 2, 3. So let's draw our vertical asymptote, and please draw this as a dotted line so that we don't mix it up with one of our axes, and the other one is at 4. So 1, 2, 3, 4. Okay. And we know that we're going to have our x-axis as our end behavior, because as x goes to positive or negative infinity, y is approaching 0. So you could draw a dotted line. It's not going to look too good, but if you're using a different, different color pen, you could draw a dotted line to show that there is an asymptote. And now we're going to put everything together. Okay. Now the question is at these asymptotes, is it going to positive infinity? Is it going to negative infinity? How do we determine that? Well, this is where determining the sign of the function is going to be useful. So I know in the interval up to -3, the function has to always be negative. And I know it's approaching 0 as x gets small, and so that means it's going to have to be going to negative infinity at this asymptote, because it can never become positive in this interval. So I can draw this function here, and you see I'm not going to go crazy trying to be precise, but I know what I'm trying to get is the general shape of this function. Okay, so between -3 and -1, we see that the function is going to be positive. Then from 1 to 4, it has to be negative. Okay, so that means that at this vertical asymptote to the right of it, it's going to have to be going to positive infinity. Okay, whereas at this asymptote, again, the function is negative in this interval from -1 to 4. So this is going to have to go to negative infinity. Now exactly how the function behaves in the middle, it's going to be, again, that's something we're going to have to wait for calculus. But I know that it's going to have to go to positive infinity there. At some point, it's going to have to cross. And then at some point, there's going to have to be some sort of squiggle that brings it back down so that it goes to negative infinity. So always positive in this interval, and then always negative in that interval. And I know this has to go to positive infinity, negative infinity. Exactly where sort of this, change occurs, who knows? Okay, this is where we got to wait for calculus. Okay, and let's go to the last part. It has to always be positive when it's greater than 4. So that means it has to be going to positive infinity to the right of 4, and it has to be approaching 0 from the positive side, because the function can never be negative in this interval. And so we can draw the last part of this function. Okay, so it's going to look something like this. Okay, do we have all the information? No, there's definitely, but like we had to deal with that fact with polynomials, same thing with rational functions. But if you check on Desmos, you'll likely see that it'll look something like this. Okay, so just to recap. As usual, step number 1 is going to be to factor and see if there's any simplifying that occurs. Okay, if there is, then you know that anything that simplifies would result in a hole on your graph. Once you've done that, you can start the process of analyzing the simplified function. find the domain, find the x-intercepts, find the vertical asymptotes, find the y-intercept. So here now what we can do is, well, I'll just call this negative 1 over 12. I can make my y-axis whatever I like, so wherever it crosses the y-axis, I'll just designate that value there. Okay? Determine the end behavior and determine the sign of the function, and then from there set up the structure. And what I mean by structure is the x-intercept and the vertical asymptotes, the end behavior, which in this case here was a horizontal asymptote, and then using the sign of the function, you can draw a reasonably good sketch. Okay, so I'm going to ask you to take a look at number 4 for a few minutes and see how far you can get. Start the process of finding these details, and then we'll take it up together. Okay, that's it.